Hello. Thanks for joining this session at our virtual conference on EV engineering. I'm Chris from Charged. The topic of this presentation is the e-mobility market and charging trends in an all-electric society. And it's brought to you by TTI and Phoenix Contact. There'll be a Q&A session at the end, so please click the Q&A button at the bottom of your screen to submit a question you have for the speakers at any time. The PDF of the slides are also available to download, and we'll post a link to those in the chat box. So without further ado, please welcome our two presenters for this session, Vince Cariotti and Lindsay Walling. Welcome.
Hello, my name is Vince Cariotti, and I'm the Director of eMobility for Phoenix Contact. And I'm going to spend a few minutes today just covering some topics in the all-electric society, along with some trends in the e-mobility sector. Why is the all-electric society important for the world? Climate, CO2 reduction, and the use of electricity in creating usable resources. The UN came up with some sustainable development goals, quite a few sustainable development goals. What we are going to focus on today is a little bit on affordable and clean energy. What we see is less and more at the same time. The world needs more and more energy so that the growing population can live in prosperity and security. We must reduce CO2 emissions to survive. The pursuit of clean energy will trigger a huge and economic technological boost. Unlimited clean energy will be the next driver of the global economy, and that is the truth. Some of the changes are made by digitalization. Digital transformation enables the conversion to renewable energy. This offers great growth opportunities for all of industries, especially the all-electric society and the development of electrification for automobiles. A world where unlimited energy is based on renewable resources without harmful emissions. Sustainable growth and conversion of natural resources to help guide and grow our energy production. Great growth and development prospects, including the market of e-mobility, which we're going to cover today. Clean energy is available in abundance. Truly, if you look at the land mass, less than 1% of land mass would be needed by 2030 to meet the energy's demand throughout the world. Excess energy can be stored. So when you're doing charging of electric vehicles, wind energy or solar energy can be stored in batteries and then transferred through the charging stations to automobiles. So digital transformation is our business. We look at smart energy, smart mobility, smart infrastructure, and smart building. Those are some of the main topics within smart systems. Electrification is what we're mainly going to focus on today. We'll touch on a little bit of networking, and automation are other areas that are being done and moving this industry forward. Empowering the all-electric society with smart solutions for all sectors. Phoenix Contact participates in all those areas: buildings, industry, infrastructure, energy, and leading in all those areas, and especially e-mobility. If we look at some of the forecasts and some of the trends, by 2040, 65% of all new car sales and 33% of the global fleet will be electric. Now, with some of the changes in the policies in the United States with the new administration, there's a possibility that some of these goals and forecasts may move forward, at least for a larger share in the United States. When you look at the charging infrastructure, it's a chicken and egg. Do we build the charging infrastructure first, or do we build the vehicles first? Well, the marketplace is evolving, and there's different approaches to providing charging infrastructure that are being deployed. And if you look at Electrify America, different electric companies and different site plans for mitigation to help with the energy, and you look at some of the different billions of dollars that are being spent, you can see the growth. There's a few entities that are investing in charger infrastructure, is surmised as we see here. What's interesting is in the new Biden policy, the $2 trillion energy package, 175 billion is planned for EV infrastructure spend, which is a large amount of money when they're looking at over 500,000 charging stations, high power charging stations in the US alone. If we look at some of the locations, you look at public DC fast charging where we need, at least 100,000 ports. Most of your charging is going to be done at home, 78% of that. Public charging on different areas, grocery stores and so on. And workplace charging is between home and the workplace is where most charging will take place. And by 2030, they're saying we're going to need an additional 9.6 million ports. So empowering the all-electric society requires smart products for smart industries. And that's where we come in at Phoenix Contact. And we're going to spend some time today talking about e-mobility. And at this point, I'm going to turn it over to Lindsay Walling, who's the product manager for our e-mobility products, and he's going to cover some of the areas and products within our e-mobility folder.
Thank you, Vince. I appreciate that introduction. And yes, I'm Lindsay Walling with Phoenix Contact, and I am the product marketing manager for e-mobility in North America. As Vince said, we will have products. We do have products for specifically the e-mobility industry. And let's take a look at what some of those products are. First of all, there are three major areas in the globe for e-mobility products, and there are different standards available for the North America, and also South Korea is the CCS Type 1 under the SAE J1772 standard. And then there is the European standard which is the CCS Type 2. And then there is also a Chinese standard for GBT. And there's also a new standard that is being released in China for the DC charging Chao-G. And that is a standard that is expected to be completed here in the next several months. So we'll take a look at each of these standards in a little bit more detail and some of the products associated with them. And we look at, first of all, the Type 1 product. And these products are rated for charging per the standard up to 80 amps. From Phoenix Contact, we have products available today up to 48 amps and also some other lower levels as well. For Type 2 European standard, these products are limited to 32 amps, either single phase or three phase. And then the GBT for the China market is also at 32 amps. We have capabilities of doing some customization, such as labels, colors of the handles. Also, we have capability of doing a lockout feature on the connectors for the Type 1 and also for the GBT in a situation where somebody may have a charger that is not in a protected area and they want to be able to prevent other people from utilizing that charging location. Then we get into the level 3 and 4 charging with the DC charging, and we have three different variations of product. First of all, what we call a C-line connector, which is rated for 40 and 80 amps. And this is a small connector with a lightweight handle, good for private charging locations and also like at homes and apartment places. And then they go to the next level up, which is rated at 200 amps. And then we go to a liquid cooled system rated at up to 500 amps. And we have these solutions in both the North American Type 1 and the European Type 2 products. We'll take a little bit closer look at these as we go forward here. Now, you look at it and say, well, why do we have 3 different levels of charging on the DC side? And the reason for that is that there are different charging requirements depending on the location of charging and the amount of time that would be expected to charge. Of course, the higher the current, the shorter the charging cycle is for the vehicle. When you're working from home, um, or when you're at home, and you may want to have some higher charging levels, and we look at either the AC charging at up to 48 amps, or if you look at the DC in either 40 or 80 amps. And again, why would somebody at home want to have a DC charger at their home location? And the reason is very simple. Some vehicles on the market are limited to 30 amps AC charging. And if you want to be able to charge a little bit more quickly, you could have a DC charger. In most cases, with CCS on the vehicle, they will be able to charge at least 125 amps. So again, it does provide an advantage in your charging time cycles. Also for other locations in a public environment, locations where you may want to be able to charge in 1 to 3 hours. So again, you may want to be looking at a 40 to 80 amp charging cable, or maybe even up to 200 amps. But these would be locations like at restaurants, shopping centers, at businesses. You go into work at the office, and your vehicle's going to be there for several hours. And so it's okay to be charging for 1 to 3 hours, or even AC up to 6 or 8 hours to get a full charge on your batteries. Where you're going to want the really high powered charging, which would be the liquid cooled systems, possibly up to 500 amps, will be along the interstate highways, where you want a fast charge time, typically in less than 30 minutes, to get your batteries charged up to about an 80% or 90% charge. So that's the reason for the different charging levels and what the importance and interest for the different capabilities are. Also, when you look at the high powered charging, 200 and then liquid cooled up to 500 amps, that's very interesting for fleet vehicles, where they're going to be utilizing the vehicles like buses or other types of equipment, trash trucks that are going to be out running all day long, and they may need to come in for a fast charge at the depot. And delivery vehicles falls in that category as well. So another area where fast charging or high current charging capabilities is of interest. So if we look at, first of all, the level 3 up to 200 amps without cooling, and then 500 amps with liquid cooling system, and also we've increased voltage capabilities up to 1,000 volts. So we've also, with this new cable, have optimized the latch operation. It's very simple, almost like squeezing the handle on a regular gasoline pump, and so very familiar with people, for use, and very obvious how to operate the connector system. Also, we have very precise temperature monitoring built into these cables. One other new aspect of this product is that you see the picture on the bottom left with a damaged face. We do have the capability of replacing this face if it gets dropped and damaged, so can be repaired in the field and does not require replacement of the entire cable. So that's a big advantage of the new generation of product. that we will be releasing here within the next couple of months. And we also have the capability not only of the mating face, but also the capability of replacing the DC contacts again with in the field or on site. From there, we now take a look at inlets that go directly on the vehicles. There are 3 different levels of product. First of all, we're looking at the CCS Type 1 for the North American market. From a DC perspective, we'll have versions for 125 amps, 200 amps, and 250 amps. From an AC standpoint, we can have either no AC lines. In some cases, the vehicle may be planned, especially with fleet vehicles, they may be planned to always charge with DC and therefore may not even need to have the AC charge lines. We can do also 48 amp AC or 80 amp AC as well. There is a locking actuator included, which is based on a 12-volt system. So we have these products are presently available and on the market. Now we take a look at the CCS Type 2, very similar standpoint here. The only real difference is, of course, it has the Type 2 interface. But from a DC standpoint, it is the same. We have capability of charging up to 500 amps on a temporary basis or 250 amps on a continuous basis. One thing that's interesting is that temporary basis at 500 amps is sufficient for the inlet side, whereas on the cable side, you want that cable to be able to operate continuously all day long, 24 hours a day. On the inlet side, that's not necessary because a vehicle will only have a duration charging at that kind of current level for approximately 30 minutes. And after that, it's the charge cycle is discontinued, and there is opportunity for the inlet to cool down from any heating that may occur until the next charge cycle. But with the cable side, you want it to be able to continue continuously charge so that when vehicle A pulls in and they charge, then when the second vehicle pulls into the charge station, they want to also be able to enjoy the full capabilities of that charging station capability. So with the, again, AC side on the Type 2 is again limited to 32 amps, 250 volts, either single phase or 3-phase, and the 3-phase is 480 volts. There's some unique benefits that we have. Again, continuous charging capability of 250 amps and temporary DC charging up to 500 amps with our inlets. We also have very precise temperature monitoring. We have integrated PT1000 sensors at each DC contact, plus and minus, and therefore we have very rapid response of the temperature monitoring, which is important for the safety of the system and performance of the system overall. Also, we have a high level of IP protection, IP67 at the back, and then also additional protection in the front area of IP 6K 6K and also IP 6K 9K. So again, very good IP protection of the product, best on the market. Easy installation. One of the unique things about the inlets from Phoenix Contact is that the CCS Type 1 and the CCS Type 2 are dimensionally almost exactly the same. All of the mounting areas are exactly the same. The face, the bracket face is the same as well. This is important for those that are manufacturing equipment and vehicles that will be sold in both North America and in the European markets. Therefore, the manufacturer only has to have one set of mounting brackets and also one shape of the vehicle body at the charge port area. So again, makes it very easy for the installation in production of the vehicles and the equipment supplied that have the vehicles that have the inlets mounted. One other area for the charging stations, we do have also controllers that are cloud-based charging systems. These are basically specialized PLCs, and they have the OCPP charging profiles built into them already. So we do have the capabilities with these. They are compatible with CCS, AC, and also CHAdeMO cabling systems. These controllers have capabilities of operating with the primary controller and then also secondary controllers for up to 50 charging spots. With that, if there's any other questions or information, please reach out and you can take a look at phoenixcontact.com/eMobility, and it can direct you to our products and capabilities on the web. With that, I want to say thank you very much for your interest and viewership. If there's any questions, we will be online in order to answer questions you may have. Thank you.
Thank you for your presentation. At this point, we will begin the Q&A session. So please submit any questions you have by clicking the Q&A button on your screen. I see that we actually have some already. Vince and Lindsay, if you would like to read the question and then answer it, that would be great. And would you like for me to leave your contact information up here?
That'd be great. Yeah, thank you.
That's fine. Yeah, one question here with the trend to high power charger is sustainable when it's known that there are some technological limitations for the EV mainstream battery. Most of the EVs can accept only 150 kW without lifetime damage. That's very true. When you're charging at high power, high currents, you can have some damage to the batteries. Although if you do that only on seldomly do that charge at high power, you're not really going to have any discernible damage done to the battery packs. So, if you are doing, like long distance traveling and you need to do fast charge from time to time, it's not really that detrimental. But you definitely would not want to be doing high current charging every day. You're definitely much better off to be charging it at lower current levels to exactly do that and reduce the amount of wear and tear, if you will, on the battery packs.
Also, the technology on these batteries are continuing to evolve too. So as we get more and more technologically advanced, the batteries will be able to handle those charging levels for a longer period of time and not, damage the battery as we go forward. So hopefully that answers your question.
Yeah. Another one, are the controllers compatible with plug and charge standards? The answer is on that. Vince, are you very familiar with that? I'm not as strong on. I'm not exactly sure what the plug and charge standard is. Basically, we have CAN bus, standard and built into it for communications.
Yeah, I think that it is CAN bus, and then the the OPP. So if there's a specific question a little deeper, we can, if you email one of us or email me, then we can get the answer to you. If I don't know what you mean by the plug and charge standard either. So I think maybe it'd be something to take offline and have that discussion if you're okay with that. Then there was another one, is the 250 amp continuous and 500 amp temporary receptacle liquid cooled. Well, none of the vehicle inlets right now are liquid cooled. Just the 500 amp CCS type 1 and type 2 for the charging station cable are liquid cooled, but right now the inlets on the vehicle are not liquid cooled.
Yeah, the reasoning being for that is that on the charge station, you want to be able to continuously run at that 500 amp level. On the vehicle side, it's not as important because the duration, the time that you're going to be charging at that level on the vehicle is typically not going to be greater than about 30 minutes in most cases. Also, one of the things that advantages is the cable side will actually also help draw some of the heat out of the contact area on the inlet as well. So that's the reasoning that at this point in time, we've not done any kind of liquid cooled systems for the inlet side of the system.
There's a lot of different questions here. They're
Yeah.
gonna take a little bit more than a couple minutes to answer, I see.
Yeah, and we only have time for one more.
Yeah, here's one. It says, for liquid cooled charger, how do you prevent deterioration of the tubes due to hydrolysis and potential leakage? First of all, I think one of the things is that our systems use a glycol water mixture 50-50%, and so therefore it's not a very caustic liquid in there, so it holds up very well. And in regards to leakage, we do also have leakage detectors in the system to prevent against that. If a leak does occur, which would be very seldom, but if it does occur, there's detection methods so that we can kind of shut that down and have the system repaired. Another question, what happens in charging when the connector is wet by rain? First of all, we have an IP55 rating on the product, and it's actually it does not really affect it. Just a typical rain event will not affect the charging situation. So I haven't seen, or even, snow or ice events. We haven't really seen any kind of issues or problems with that.
Well, thank you so much. I'm sorry we can't get to all the questions, but definitely reach you. Their contact information is right here on the screen, so you can feel to reach out directly with your questions. And thank you, Lindsay and Vince, so much.
Oh, you're welcome.
Thank you.
Thanks, everybody. Appreciate it.